Hello and welcome to today's Infopedia web conference. This is Fast Track Dynamics 365 for Operations Tech Talk. Today's topic, Retail Architecture and Retail Store Scale Unit. Presenting for us today from Microsoft, we have Senior R&D Solution Architect, Murali Kumanduri, and Senior R&D Solution Architect, Andreas Hofmann. So without any further delay, Murali, over to you.
Thank you. Hi, in today's session, we're going to briefly look at the solution architecture for retail components, look at each of the retail components in detail, look at various deployment architectures, and as well as do a demo of retail store scale unit. So if you look at overall retail architecture for Dynamics 365 for operations, you will look at HQ components that are hosted in Azure. These consist of retail server, AOS, and then Cloud POS server. And in addition to this, we also have one of our channels that is hosted in HQ and renders via browser, being the call center. Then other components of our solution architecture include integration with e-commerce, retail stores, which are either hosted with hosted retail server or channel database, and then retail stores with retail store scale unit. And let's dive into each of these components in detail and look at how these have been implemented. So with Retail HQ, basically, this is our solution for maintaining all of the retail information, including master data management, merchandise management, catalogs, assortments, all of this hosted in HQ with Azure database at the backend and with a browser-based HTML5 client, and that's optimized for user experience. This basically is also hosts our call center channel, and basically the call center agents can use this for order management. We can also use this for other aspects of fulfillment in retail, like supply chain and other aspects of it. We also have, as a component of HQ, we also have the CDX Commerce Data Exchange. This is used for data replication between HQ as well as for channels. The channel database can either be part of the hosted Azure, SQL Azure, or it could also be part of the stores. So we will dive into that a little bit as we go into the presentation. Now, the CDX portion is also responsible for extraction of data from HQ and making that available to the stores. Retail server is our business logic engine, and it works as a web service, IaaS web service, and it makes a stateless OData calls. And core of our business logic in terms of how our applications work are hosted in retail server. One of our components that we have for point of sale is the Cloud POS, and the Cloud POS is rendered via an IaaS web application. It has exactly the same code base as modern POS and connects to the channel database that is hosted in SQL Azure. And it's a cross-browser and cross-platform application, basically runs in a browser across different operating systems. Now, some of the other components that we're going to look at in detail are the modern point of sale. So the modern point of sale is our Windows 10-based UWP application and runs on the actual device. And it can render itself in multiple form factors. So depending on the size of the device, the resolution of the application is adjusted based on it. It works in a connected mode, talking to either the cloud-based retail server, or can also talk to the retail server in the stores. And then has a capability to work offline if there are connectivity drops from the stores. Modern POS also has inbuilt capability to synchronize data from HQ. So it has a CDX component running inside of modern POS. The next component we're going to look at is a Cloud POS. It's basically a browser client running exactly the same code as modern POS. It's a cross-platform and cross-OS, so it can support multiple browsers, and connects to the retail server and the channel database via retail server, which can either be hosted in the cloud or in store. Now, being a browser application, Cloud POS has limited device capabilities that it can connect to, and would require a hardware station to connect to the peripherals. And it does not have offline support. Basically, it requires you to be connected to the HQ or to the RSSU. And finally, this also supports it's based on a Xamarin Shell app. So we, as part of Retail SDK, we ship with a Xamarin Shell app and also run natively like an app.
One thing I want to add is the modern POS offline version has a built-in CDX asynchronous client part. The online version does not have that built in because that synchronization happens through the last one on this slide, the CDX async client, which synchronizes the channel database itself instead of MPOS.
The next component that we're talking about is a hardware station. So this is the component that interacts with devices and peripherals in the store. There are two types of device it works with. So it's like in process or IPC that is part of the modern POS itself, or you can have a separate component called hardware station that is an IIS-based website which interacts with the peripherals. And we support all of the standard OPOS device peripherals that are available in the market. And then we're specifically working on certifying with various manufacturers and ensuring they are compatible with our software. Next component is the channel database or offline database. So we, as part of the channel database hosted in HQ, we have SQL Azure. So the channel database is part of the AXDB itself and uses a different schema. The in-store, there are various devices, so you can have an offline database, which is in store along with a device. And also there's a channel database as part of RSSU. And that can be various versions of SQL. So we support right from SQL Express to SQL Standard and different editions. And this is dependent on your need as a business in terms of data volumes. And then finally, with RSSU or Retail Store Scale Unit, we have a CDX Async client. That's a Windows service and is responsible for synchronizing master data to the channels and synchronizing transactions to the HQ.
Now that we have learned about all the components that the retail solution comprises of, let's go a little bit more into detail what actually has been new since update 3 or the 16.11 release of Dynamics 365 for Operations, which we call the Retail Store Scale Unit. Murali has already mentioned this. It's basically a way, you can see this in the diagram here, it actually allows us to move a few of the traditionally server components down into the retail store or even possibly other locations, in order to get some of the benefits out of this. Some of you may remember in 2012 R3 version of Dynamics, we also supported a channel database in the store. This is basically the equivalent feature to bring this same scenario and the same advantages into the store. So you can see we have a symmetric architecture where we have now the retail server, the Cloud POS IIS website, and the channel database all close or in the store, close to our store, which of course helps us with some of the advantages we'll talk about later. We have flexible, simplified deployment. Mostly what that means is it's exactly the same components, the same code, the same customizations, everything deployed the same way. So this is possibly also something that someone can decide later if they need to go or want to go with a retail store scale unit, or if the Microsoft hosted cloud version of these components is enough for the implementation for the project. Of course, in a modern application, everything is secure. The communication is secure. Everything must be SSL-based communication, and authentication is done via Azure Active Directory service-to-service authentication, which is set up during the deployment, during the installation, with very little additional manual steps. Basically, AX will allow a certain token to be used to create the authentication ticket, and that needs to be configured on both sides, so we have a secure communication and authentication. Of course, modern POS and cloud POS both run in the retail store just as before, but now the difference is, of course, that these components live much closer to the server components, which gives us some of the benefits that we have that we'll talk about. Also, already here on this slide, we're basically reducing our network latency substantially here. Since in most cases this is a local area network, we have hardly any latency here and also no bandwidth issues. Okay, I'm going to do a quick demo of the retail store scale unit. So I have an environment where I have deployed a cloud box and a retail store scale unit box, and I'm going to show you two different cloud POSes that talk to basically to the different endpoints, the OData endpoints of retail server. So the first one I'm going to show is the actual RSSU. Very quickly to verify in the settings here in modern POS, you can see, I can make this a little bit bigger, that we are hitting a retail server at RSSU Boston retail and so on. So we can see that clearly this is doing some local is carrying out some local traffic here. Let's search for an item. Let's add this item. Everything works the same way. If we had this cloud, this store unit and the client physically closely located, we actually would see a big benefit in performance, which is something that's a little bit tougher for me to demo. I'm just going to check out, and then I can leave it at this. But if we look at the traffic here, we can clearly see that these requests all went to the went against the RSSU Boston retail, which is something that is configured in the AX during the profile setup, where basically the Boston store was configured to be hosted or to be run by the local scale unit. The second one I wanted to demo is now this one. You can see that I'm actually in this point hitting a cloud environment, and this is now my Houston store. Other than that, everything works the same way. I can operate against the same data. In this case, it's a different store, so I have slightly different products. This is, of course, supported. We have had this before, so there's no difference whether the retail store or retail store scale unit is hosted in the store, or whether we use the cloud version. Everything stays the same. If we look at the traffic here, looks like this didn't work, but we actually can see the link here. One last thing I wanted to show is how is this actually modeled in AX. So this is my AX. So most of you will be familiar with the concept of a channel database. So how this was set up initially after we had this single box environment, we basically created a second channel database and assigned the specific retail channel Boston to that channel database. And by doing this, removed it from the default channel database, which serves all the other stores. So there's a lot of flexibility here at play or possible. Another thing is, in order to install the database, there's a download button here in the AX user interface, which allows me to download the correct version to download the correct version, and this can also be configured since there are multiple versions available. So you can see there's multiple updates and hotfixes installed. So this is something that's configured once, and then the download is being used to bring the correct package down to the store.
Next, we're going to look at the different deployment architectures that we can have and dive into what are the different possibilities with our solution.
So now you learned about all the different components, and one example that I showed in a demo. What we often get the questions, well, what option is best for my project? And that's something that often is not as easy to answer right in a 5-minute conversation. And that's why we made the effort here in this talk to dive into this a little bit more. We'll show you a couple of examples here on this slide, and then we'll talk about a couple of considerations that are actually important. So you can see here in the middle, we have the headquarters in Azure. This is right now the only option. But in a future update, we have also on-premise releases. For now, for this talk, let's assume this is always in Azure, and we have a load-balanced system of multiple front-end machines, and we have always automatically deployed a retail server, cloud POS, IaaS web application with the AOS together. So the first scenario could be on the left here. Number one, we see it's a simple brick and mortar store with cloud POS. So let's say in this example, we wanted to have flexibility of different device. Let's say a different tablet with a different OS. So cloud POS was chosen here. Since some special hardware seems to be required in this project or in the store, we have a hardware station here at play as well. This is, as Murali already mentioned, Cloud POS does not have the permissions to talk to the OS drivers, or the browser does not have that. So therefore, we use a hardware station that allows us to relay some of those OS low-level peripheral calls. In the second case, down below on the left, you see now we have two modern POSes instead of the Cloud POS installed. And one is the online version of the modern POS, and the one on the right is actually an offline version. As you can see that here, that's shown because we have a little SQL database as a symbol here attached. Most of you know, so we'll support an offline mode for modern POS, which includes an embedded database that hosts the data so we can truly be offline without any network connectivity. There are certain advantages and disadvantages, which we will dive into more later. In the third option, you can see we can also have Cloud POS and modern POS together, or modern POS in offline mode here. That's all supported. And in this special case, also a hardware station is used. Cloud POS, as we talked about before, usually needs a hardware station for more complicated hardware anyway. And modern POS in this case uses the hardware station as a backup device. So that's some retailers opt for the solution where you have a backup in case a hardware device itself fails. You can basically just in the UI switch and use a shared station instead. Number 4 on the right, lower right. This is the store with the retail store scale unit, which I demoed earlier. So we have the box with the lines. We have all the server components now moved down close to the terminals, which gives us the benefits of faster scans, lower latency, and also a bit of more reliability, and we're basically not as dependent on the internet connections quality. And then in the top right, we have e-commerce, which many of you know. We basically provide an e-commerce or online store SDK, which can be hosted in other systems, other applications, in order to integrate with other online store applications. Consumer app is also as part of the retail SDK, which is basically a starting sample that can be used in order to understand what's possible, and people can use it as a template and implement new consumer apps based on that sample code.
With each of these architectures, there are various considerations that we, in the implementations, that we need to use to choose the right architecture for the customer. So we wanted to dive into each of these considerations and look at what factors and what requirements would determine the right architecture for the customer.
And one thing I wanted to add is also some of these considerations may also a little bit working against each other. So they all have to be considered. As it is normal, sometimes there's benefits and also disadvantages with a single option. So these things all have to be weighed against each other. So as the first consideration, we highlight here the fact, just a difference, again, as a summary between the cloud-only retail server versus the retail store scale unit. This is important to consider is what customer workloads are at play here in this project. For example, when we have very large networks of stores or even terminals, we're actually in the cloud workload, we're actually hitting all the way into the same database. Everything goes together in the cloud database. The AOS and channel database is hosted together. That has an impact, and scalability impact on our headquarter, or can have. So that might be one consideration to opt for the retail store scale unit, depending on the size. Another one I mentioned already earlier is the network performance. Slow speed networks or high latency, bandwidth, all these things can, of course, hamper the user experience and increase the speed of the application. If every call needs to go back to the cloud. So that's another reason for some to decide that a store scale unit that is located closer is important to them. Of course, on the other side, maintenance. This is a direct opposite advantage use case now. The companies that need to install the retail store scale unit, of course, have to deal with higher maintenance cost. There's also cost of certificates, database, and SQL license in some cases additionally required. As I mentioned before, SQL Express can be used for both modern POS offline and the scale unit. Allerdings for this but for the scale unit, that's after a certain number of terminals likely not going to result in good performance. So an upgrade to another SQL license is required at that point. This is something that needs to be considered. The size of the store, of course, and the number of traffic and the number of items, all these things together have an impact on which decision should be taken here. Also, as I mentioned, as I showed in my demo, a mix of both solutions can be used. So in my demo, my Houston store was served from the cloud, and my Boston store was served from a specific next one is the consideration between, or it is the comparison between cloud POS and modern POS. So we already showed some of these examples in the slides before, but basically both of them require to access retail server. This is the same, so there's no difference here. Latency, bandwidth is all the same. What's different is that Cloud POS, every time when a new window is started and after a certain amount of time, the authentication token needs to be refreshed. Therefore, there is access to the Azure Active Directory is required to run Cloud POS successfully. Modern POS is a little different. Modern POS only need access to Azure Active Directory during activation, and post-activation, we're actually using a device token, which is a secret that is communicated between the modern POS and the retail server. So Azure access would not be necessarily required after the activation. The main big difference, of course, Cloud POS does not actually need to be installed. We just point a browser. Of different types of browsers are supported. We just point the browser to the URL and we activate the browser instance, and that's pretty much it. Modern POS, we also activate the instance by pointing to the retail server URL, but we can only do that after an installation has taken place. Modern POS also needs to be considered, requires a code signing certificate if any type of customization or extension has been performed by the partner or ISV. And the reason for that is that the only modern POS package that Microsoft ships uncustomized has already a valid code signing certificate. So some people might have seen this. If you play with customizations and make a change and recompile modern POS and install it, you will get a warning about the signing certificate not being trusted. Last but not least, hardware requirement and staged rollout requirements are important for these things to consider. Staged rollout, for example, would be if a small bug fix needs to be rolled out. I have the opportunity to maybe update only 5 terminals for modern POS to the new version, make sure everything works, and then move over the rest. That's a little tougher to do with Cloud POS because we have a single server deployment here. So a little bit more about the hardware considerations as a continuation from the previous slide. CloudPause supports simple keyword wedge devices natively. This is just the fact is that the Windows OS or the browser does not allow to access closer down to the native peripherals, which is something that modern pause allows. Therefore, modern pause can deal with all the hardware without necessarily needing a hardware station. But CloudPause can use a hardware station to basically access the same hardware also. And as shown already in the slide before, hardware stations can be shared between two as backup, for example, or for other reasons. Also, with the latest retail SDK, we're also shipping a Xamarin Shell, which allows us to host CloudPause in a shell that may allow us to have different hardware support and run on different OSs. This, of course, requires that that shell actually, or that manufacturer provides a driver for that Xamarin Shell. So last but not least, CloudPause versus modern pause in terms of maintenance. As I mentioned just briefly, CloudPause is a server component with a client running in a browser. So it's a single deployment that would help us update multiple registers at once, as opposed to modern pause as a client component. We'll actually have to install the client n times for each terminal. Mass deployment is definitely something that we have heard from the community, and we're investing into this. And some of these scenarios actually were supported in 2012, and we're basically looking into bringing these back. CloudPause requires only a browser, no other footprint. Therefore, we can run on different OSs as well. Modern pause, starting from the 16.11 release, is a UWC Windows 10 application, which means it requires Windows 10 or Windows Server 2016. For the developers on the call, that means when you download the VHD, you need to pick the 2016 server version. I already mentioned the multi-staged rollout in the store, but not just for small pilot releases, but also for N-1. This might be an interesting scenario where we can have, of course, running different modern pause instances at different versions. This is tougher to do for CloudPause. I'm not saying it's impossible, but this is not supported right out of the box. Both, as mentioned before, both of these clients can be mixed in a store, across this store or across different stores in the organization. Now let's take a quick look at the considerations to take for pause versus modern pause in online only or offline mode. So we have the capability to host a small database, or to host a database for offline mode, which basically brings all the data down close to the terminal or onto the terminal, that allows us to be fully offline and still be able to take sales and look up products and do most of the functionality, carry out most of the functionality. This offline mode requires no network, whether it's wide area network or local network. The offline mode will not work with CDX real-time service calls. So there are a couple of calls that go all the way back to headquarters. These calls are not supported in the offline mode. Also, these calls, the more calls there are of this nature, they are usually working against scalability of the whole system. So these should be taken, should be considered wisely how many of these real-time service calls exist in the solution. So again, SQL Express is an option as the database, but of course there are limitations. So some customers need to look into using larger databases or faster, more scalable database solutions. So licensing cost has to be considered there as well. So multiple, also as a disadvantages of offline mode, the terminals themselves, once they are in offline mode, cannot see each other. So that is possibly a caveat that many people can accept, because offline mode does not happen very often, but it is definitely a point to consider. So cross-terminal scenarios are not possible in offline mode. Versus in online mode, they are of course possible between modern POS and also cloud POS. So what about our internet speed and reliability? What are the things that need to be considered there? As I showed earlier, the scale unit helps to scale the calls if we are closer to the scale unit versus the cloud. That's actually something that can be demoed very well if for instance my headquarters would be hosted in a different Azure data center. You can clearly monitor the calls to retail server taking quite a bit more time because all the latency that you have between your local POS client and the retail server, of course, have to be added to every call. As mentioned before, modern POS with offline mode is a consideration for really bad or no internet connections. But of course, we need internet connections at some point in order to synchronize master data and transactions into the appropriate direction. Mix of the two options is possible and supported. Of course, if we have both a retail store scale unit and offline databases, now we actually have more synchronization happening because there's actually 2 or more databases involved in the solution in the store. Another important thing to look into is multiple different geographic regions. We have customers that have different operations on different continents, and it is quite common to see latency of 200 to 300 milliseconds between those regions, which makes it suddenly very slow when quite noticeable slower, let's put it that way, for some of the operations in the POS client if retail server is overseas. That is a good example to consider the retail store scale unit. In fact, a good scenario would be to consider a scale unit either in every store or possibly only in each region, and then have multiple stores share the respective retail store scale unit. That is also a scenario. And also, last but not least, downtime window for releases. By having multiple geographies, we have to consider that it's for many customers it is almost not possible to have any downtime because business time, there's if multiple different continents, business times overlap not very much. So therefore, we have to really be careful of having a single cloud deployment. So the use of retail store scale units or also offline mode might help strategically with these scenarios as well.
Next thing we need to consider is the commerce data exchange. So most of our implementations require master data to move between headquarters and the stores, either the channel database in the HQ along with the retail server in the cloud, or with RSSU as well as offline. So Commerce Data Exchange basically uses SQL change tracking. So every table level change that is part of the retail channel schema basically is tracked for changes. And then we have an internal logic that ensures for a distribution schedule or a job, a tracking is done to what data has been sent to what channel database or offline database. And then the data is what is sent is filtered by a data group. So a set of stores or databases that are part of a data group share the same data. Now, the critical difference from older versions of software is that we no longer have CDX async server. Now, this is part of the AX batch framework itself. So when a distribution schedule for a job is pushed, the data is extracted using the batch jobs. And then if you're using the channel database in the cloud, then there's another batch job that runs and writes the data. In addition, what happens is there's one file generated per database in blob storage. So imagine you have a store with large number of terminals with offline. In addition to one for the channel database, there's also a file generated for every offline database. Then considerations that we have to look at in such scenarios is if you have large number of stores as well as large number of modern POS with offline, then the extraction and populating of the channel and the offline database could be time consuming. So it's critical that the way the master data is generated, the change tracking is also effective in the way it comes in. So if you have upstream systems that are sending data, then it's important that we ensure the data that comes down to the AX or Dynamics 365 for operations should be minimal and is based on changes only. So the most important considerations, I would say, are looking at whether you have RSSU and how many RSSUs you have, along with offline databases when you look at the design of deployment architecture for a customer.
So with that, we have some time to go into some questions. We actually will see the questions if someone submits them, and we have a couple minutes left that we can use to spend on these questions.
All right, thank you. All right, ladies and gentlemen, if you'd like to ask a question, go ahead and type your question into the white text box on the messages panel. We are here. We're going to go ahead and wait just a couple of seconds to see if any questions come in. In the meantime, I'd like to bring your attention to a survey link that I popped into the messages panel there. That's a link to a short survey for this web conference, and we ask that you please take a moment before logging out to access it. We hope that you found today's information helpful, and if you enjoyed today's web conference or have feedback on how we can provide you with a better event, this is your chance to let us know. The survey scores are on a scale from 1 to 5, with 5 being the highest score possible. And I'm going to go ahead and check the Q&A panel, see if any questions have come in. I'm not seeing anything. Are there any final thoughts that you... Oh, wait a minute. We do have one question in here. I'll go ahead and hand it back to the presenters, and they can go ahead and address that.
How Retail Scale Unit will connect to Azure is the question. As I mentioned earlier, the Scale Unit uses Azure Active Directory for authentication. That's server-to-server authentication between the retail server and the AX, and also for the real-time service calls. Other than that, it's not using Azure for many other things. It's mostly for authentication because since you know, for Dynamics 365 for operations, all our authentication model is based on the AAD. That's pretty much the only reason why Azure is accessed today. There might be some smaller features on the side, like machine learning, but just for the normal functionality, what I demoed, it's mostly used for authentication. Are there any other questions? (2012) R2 and modern POS on Windows 10 Pro. Windows 10 can be used for any type of different version of modern POS. When I mentioned that Windows 10 was required, that has changed only in the latest 16.11 version. Older releases will also be able to install on Windows 8.1 OSs.
Yeah. Additional point on this question was like modern POS is not able to see RSSU using the URL. So this would mean is that it's also based on SSL certification. So you have to verify between both of these machines if SSL trust is available. So when you browse to the retail server URL, do you see a certificate error in terms of machine name? Sometimes if they don't have a fully qualified domain, then you would need to actually install the certificate that is on the IIS machine for a retail server on the modern POS device, and then have to establish a trust between modern POS as well as the retail server.
And additionally, of course, I don't know how you are trying this, but if you do this on a test environment, you may actually need to also use host file entries in order to hit the remote retail store scale unit, unless you have actually DNS set up for that.
So one additional question we got is, do we need to install a sync client on retail scale unit to sync data with HQ? Yes, so the CDX async client, which is a Windows service and is a part of the package for retail scale unit, has to be installed on the channel database to synchronize the data. This is exactly similar to we had it in AX 2012.
Here on the screen, you can see this is the scale unit as it is installed on my demo box. So you can see all these components are automatically installed. I only had to run a single installer, and you get automatically the async client installed, which takes care of all the synchronization.
Next question we have got is how to register Windows Server 2012 R2 to AAD. So it's not the Windows Server that you're registering. You're creating a Windows, an Azure app, and you are basically setting up a client ID for that, and then you are configuring the client ID in the retail parameters, as well as on the Dynamics AX backend. There's an Azure application section where you configure that, and then you provide the same client ID when you are installing the retail server.
Yeah, basically there is a good wiki page about that. If you go to the wiki and to just search for retail store scale unit, there's two. One is a high-level discussion, and one is a very detailed installation step-by-step. This is a very, very helpful links. Is there anything that will be changed in the spring release comparing to the presented info? The presented info is unchanged by the spring release. As far as I know, the spring release is mostly about changes regarding the extensibility model, which is not something that we really talked about in this talk. But there are quite some changes in that area, but just from the deployment model and the different components, there's hardly any changes in spring release.
The next question we had is we would appreciate more info on SDK that you mentioned. So if that's the area that interests you, there we can also do a session on extensibility at a later date as well.
All right. Well, thank you guys. All right, ladies and gentlemen, that's brings us to the end of our Q&A session. So we'd like to thank you for participating today and viewing our session. That's going to wrap up today's session. Attendees can access the web conference recording via the same registration site used for today's broadcast. I'd like to extend a big thank you to our presenters, and thank you, audience, for logging in and joining us today.